Hey, good day, good evening, everyone, whatever the case may be. Thanks for joining this webinar on how to make building infrastructure smarter with LoRaWAN. It's brought to you by the LoRa Alliance, and members of the Smart Building Work Group will be participating and presenting to you today. So a couple intro slides. For people that are not overly familiar with LoRaWAN, it is a major component as to why buildings are getting smarter, and I don't think there's any doubt that the industry is moving towards smarter buildings. So why is LoRaWAN ideal for this? For one, it offers a fantastic power consumption, which is great for battery-powered devices that have to be placed in hard-to-reach locations. Quickest way to kill ROI on a project is to have to go replace batteries all the time. Human intervention is always the most expensive part of any project, and so long battery-powered devices, life devices, are ideal for collecting data. It isn't a standard within ITU now, and is a product of the nonprofit LoRa Alliance, and is such as an open, non-proprietary standard. Fantastic coverage and range from single gateway. Many buildings can be covered with a single gateway. Extremely good noise interference characteristics, and can even cover outside of buildings very easily. The architecture is inherently redundant, so if you the data you're collecting is very important. You automatically get redundancy by deploying multiple gateways. And there's a wide ecosystem of devices and gateways that have been developed over the last 5 to 7 years by members of the LoRa Alliance and those that are not members of the LoRa Alliance as well. At the kind of the top of everybody's agenda corporately these days is ESG goals. Lots of social pressures and investment pressures, but also the realization that it's just good business these days. So, and it can save companies money. So monitoring and controlling things remotely is a perfect use case for IoT. In many cases, you have to prove compliance with regulatory requirements, and to do that, you need to collect data. And you combine the fact that we've got these fantastic wireless protocols with long battery life now, you combine that with cloud computing and advanced data analytics, and you know, the ability to analyze data, collect data, and utilize that data is easier now and more cost effective than at any time in history. So quickly, I will review how you could use LoRaWAN in you know, sort of an existing building automation environment. The difference between these two drawings here, I won't go into great detail, but essentially the left-hand side of the drawing shows how you can use traditional BACNET devices and carry those over a LoRaWAN network wirelessly. The right hand of the drawing shows how you would use LoRaWAN-enabled devices and then integrate that data into a BACNET or other building automation system. Today, we're going to mostly be talking about the right-hand side of the drawing here, but you can certainly do the left-hand side as well. We'll move on now to Dan Quant from MultiTech. MultiTech's a longtime member and supporter of the LoRa Alliance. Really appreciate that, Daniel, and interested to hear what you have to say.
Yeah, thanks, Byron. Founding member back in 2015. It's been a long journey. Today, I'd like to take a few minutes to detail how the success of LoRaWAN is in part due to the flexibility of how a LoRaWAN network can be operated and deployed to best meet the needs of the application. The network agility of LoRaWAN has a big impact on the performance, the business model of an application, as Frederick highlighted earlier, not to mention the return on investment and the ongoing financial payoff for the entity paying. The basics, right? In any LoRaWAN application, just like a cellular or an Ethernet network, you provide the end nodes. Likely a capital expense, And you need to be able to retrieve the data into your analytics platform, your business system, like an ERP, or even perhaps a control system. So these are the basics with LoRaWAN, the end nodes, perhaps sensors, and how are you going to get that data into your platform. So the key decisions that have an impact to the performance, the business model, and the financial payoff include the model of how to achieve this. So is that going to be a sensor to cloud model? Is it going to be a sensor to a control on-prem control system? Are you better off using a public carrier? Does your application perhaps dictate a private network investment? And how do you architect the network, a more centralized approach or perhaps more distributed? So let's have a little look at some of those options, shall we? So sensor to cloud, right? Very easy model, being used extensively in the industry today. Essentially, LoRaWAN sensor into a gateway, into a cloud-based platform. And this is the quickest way to scale. It's simple to gather, access, process, visualize, and analyze data. It all comes up to a central repository where you can do all of these things with your data. There's no custom network or system integration. It could be just as simple as cable tying a sensor onto a motor or a generator, and then seeing data appear in your application within a couple of minutes. And the way in which you pick up your data from the application server is likely a standard internet protocol like MQTT or HTTP. So again, doesn't require any OT skill sets. And this is ideal for sensor harvesting applications like condition-based monitoring of motors and pumps and out-of-spec alerts around environmental conditions, alarms and updates when the heat of something goes above a certain level or perhaps below a level. Where sensor to on-prem systems have a lot of advantages is where you don't want that data to ever leave the building. Perhaps it's very secure and you want to keep it on-prem. You want to be able to maybe lower your OPEX costs so that you're not running up costs for cloud-based compute and storage and the backhaul costs to get the data up there and back. And perhaps you want a more resilient approach whereby you're defining the network in order to make sure that you have redundancy, maybe. And this is ideal for control systems, typically closed loop control applications like lighting, heating, ventilation systems, access control, security systems, all the types of applications where you want that data to remain on-prem and feed directly into that on-prem control system. So now how to decide what kind of network you want here. Remember, you always supply the end nodes. You're the one pulling the data out of that network. If you go with a public carrier, maybe you have coverage around you, so it's very simple to do that. Maybe you don't have coverage quite where you want it, so you can perhaps even invest in some gateways, and you can take those gateways and subscribe them to a public network server service, and you can configure your gateways to pack it forward in there, and by doing so, you've essentially increased the reach and the capacity of that public network to better service your own end nodes. So let's look at some of those advantages. So obviously there's a low capex expense. Maybe you use your own gateways, maybe you don't. But you don't have to spend too much money building out a network. The network is there for you. You get great mobility if you're trying to track assets moving between buildings across a whole country that's perhaps covered by a LoRaWAN network, France being a good example of that. Then you have full nationwide mobility. And you have that speed of deployment, a little bit like the sensor to cloud model. The network's all there. It's just about connecting assets, pulling your data off in a few minutes. The disadvantages are that OPEX cost can eat you alive. Those ongoing fees per device. So 1 million devices on the network, you buy another one, then that's 1,000,001 devices that have an ongoing OPEX cost. And coverage limitations may be an issue, although with LoRa you have the ability to bring your own gateway model. And probably not always the greatest approach for integration and control of local systems. A private network, on the other hand, provides you that lowest OPEX cost. You're not paying per endpoint for 1,000,001 devices or something. You build the network for the capacity that you need, and really that's your cost, the initial build-out cost, and of course the maintenance of that network that you've put in. You get that data privacy and protection because you've built the network. You get a deterministic performance exactly where you need it for the application that you're trying to service. And with that comes a great deal of control and resiliency that you can put in place. Of course, the disadvantages are there are initial build-out costs. So if it's a few sensors that you're trying to connect, this is going to be a high CapEx expense. But if you have a number of sensors in a facility, perhaps you'll see a return on investment in maybe as little as 9 to 18 months. Particularly if your assets are clustered in that environment, which is a key disadvantage here. If your assets are scattered all over a region, a county, a state, a country, then a public network provides you that greater nationwide coverage. So now let's have a little look about a private network. Remember, you're always providing the end nodes, you're retrieving the data. You're definitely in this model going to have to provide your own gateways, but you're also going to have to provide your own LoRaWAN network server. Maybe that's a public or private cloud, maybe it's on-prem. But that's the real addition here. You're now having to take control of that core network element, the network server. So let's have a little look at that model quickly. So end nodes like Keros water sensor, which you're going to hear about in a second. When one of those end nodes, those sensors first join the network, it does a join request that goes into the gateway. All of that messaging is sent up to a centralized network server that's typically in a public cloud, but could be on-prem in a building as well. And if you're a sensor in that network, if you're registered for that network, then you'll get an accept to come back. And now in blue, you can see how the payload now goes into the gateway when there's something to be said. And that payload is also pushed up to a cloud or on-prem network server, and that data is routed to the application server, which is where you pick out your data and you send it to your building management system or your Azure cloud or Amazon or wherever you're sending your data. So advantages is that simple integration. You don't have to manage too much about how the network server is working and performing. You just need to be able to capture the data in the gateway and push it to the network server, and then pick it up in the application server into your platform. So great network, device management, all built in, low maintenance, fast onboarding. But you have no edge intelligence or decision making down at the edge. And of course, you've got the OPEX costs of now having a network server, and you have increased WAN backhaul costs. And typically, if you're in anywhere of a slightly built up environment, you're typically going to be servicing maybe 10% of your own sensors, and you're going to be backhauling up to 95% of other sensors that are in networks around you, which once they get into the network server are disqualified because they're nothing to do with your network. So that's quite a lot of data being pushed back on the backhaul that's essentially garbage. So, point to bear in mind, you're paying for that backhaul cost. And you may well be on shared network resources with contention with others. But this is ideal for wide area networks, and it's ideal for sensor to cloud applications like occupancy detection in order to optimize where in the office perhaps you want to clean more based on foot traffic. Lastly, let's have a little look at distributed network architecture. So again, sensors, applications, they join the network. This time, the network server in this example is distributed inside the gateway. And so now we can have whitelists and blacklists of the sensors on these networks. And we're not backhauling anything that isn't already part of this network. Any of that garbage data from other sensors on other networks is immediately removed. If that sensor is part of this network, then it's provided a unique set of keys, so it's very securely protected at the network and the application layer, and that data is served up to the application server into a custom application that is retrieving that data and pumping that data directly into a building or facility management system, perhaps using a native protocol like Modbus, BACNET, or MQTT. So advantages is resiliency, privacy of data, and the security of that data because it never leaves the premise. You get the full compatibility with the LoRaWAN ecosystem. You get the edge intelligence that provides you that direct and native integration to a building management system with those reduced WAN backhaul costs, along with zero-touch network deployment and endpoint authentication and joining into the network. And this kind of architecture is ideal for connected, clustered assets on a central control system, the kind of applications like lighting control and access control systems. All right, back to you, Byron.
All right, thanks, Dan. That was extremely important information. I know when I talk to people, there's sometimes misunderstanding about what LoRaWAN is and what it isn't, and pointing out that you can go from completely public network access with cloud-based storage, outsourcing everything to keeping everything on-prem is a very important point. You can own your own network, do all the processing on-prem, all that kind of stuff. Great points to be made. Okay, let's get on with the questions and answers here. I have to say, I've done a few of these webinars, and we have some really good questions today. Excellent job. So I'll just kind of get it rolling here. So I'm gonna throw one out here about sort of involving public and private networks. So I'm going to kind of combine two questions. With the distributed network server, where the gateway has the network server in it, does that mean we have to log in or input each independent gateway for network server admins separately instead of a centralized cloud network server, or are these edge gateways also controlled from a centralized point? And I'll kind of ask a corollary question to that. But Dan, do you want to address that first?
Yeah, sure. So a distributed architecture doesn't necessarily have to run the network server in the gateway. It could be locally in the IT room connected to a number of gateways in that facility. But it's a good question, Jose. Yeah, in a simple configuration where perhaps you run the network server in the gateway, maybe you're doing a POC and a trial, then yeah, every time you want to update how that application is reporting, change whitelists, blacklists of endpoints, you physically need to log into that gateway to access the network server to make those changes. However, there are ways in which you can centralize all of the management, and this is really idealized. You get your cake and eat it, because you have all of the user data distributed at the edge, connecting LoRaWAN sensors into, I don't know, BACNET building management system. But then you centralize all your control of these networks with traffic policy, security policy, and you can service endpoint requests for unique keys and rekeying of those devices. All of this can be done centrally for one network or a whole group of networks into a common account. So in a simple sense, you have to distribute everything, but for scalability, you only distribute the user data and you centralize control.
So here's one from Francisco. What protocols are recommended for the back end? Are you using LoRa just for the sensor information / collection?
One of the question here was what protocols are recommended for the back end? Well, in a sense, that depends on your back end, doesn't it? As David just said, maybe a SCADA system uses Modbus, a production piece of equipment uses OPC UA, building management systems actually use all of these protocols and BACNET and others too. And so it's really that back end that dictates the protocol that gets used. And this is where the disconnect comes in. We're collecting data off of sensors that are often battery powered in awkward to reach places, limited to maybe no more than 11 bytes in the US. And how do we now integrate that data into a backend that's expecting to see Modbus, OPC UA, or BACNET? And so where do you now do that conversion? In some instances, you can literally do this on a sensor. Yeah, a basic Modbus implementation can be done at the sensor level. It's designed essentially for a constrained interface. But other protocols like OPC UA and BACNET, for example, there's no way that those protocols are running on a constrained interface. So now that integration needs to be done north of the network server. And so this is why I highlighted how these internal closed loop control systems, how doing this on-prem makes a lot of sense, because sending all of that data up into a cloud to then manipulate that LoRaWAN data into a format like Modbus to bring it all the way back down into the building, architecturally just isn't particularly efficient. So really it just depends on your back end. And there are many protocols out there that are phenomenally successful and have been deployed all around the world. Building management systems.
One question here, Dan, in 30 seconds, if you can. A question about the basically security. You know, are there any concerns, things to keep in mind when edge devices are compromised, aka physical unauthorized access as opposed to centralized cloud data? He's trying to compare the edge gateway security versus cloud security.
Yeah, I see that. The two types of main attack vectors, the man in the middle attacking over the air interface, and then of course the physical access to devices and sensors. So bear in mind that these private networks are inside private facilities with, you know, gated entrance and card key access. Not to say it's impossible to tamper with the hardware, of course it is, but you know, these are secure environments typically. It's not like the general public just walking past. So there is a level of overall security there. The actual security of the sensors to the gateway, to the network server, this is all baked into the LoRaWAN specs and it's highly secure. So that man in the middle attack is not there. Unique keys, for example, being used. The gateways have to have, you know, passwords. They have to be unique passwords. They're not the same passwords across a fleet of gateways. The cloud-based platforms that centrally manage these distributed architectures are all tested against SOC 2 compliance. So it's really much the same. If you've got physical access, it's for sure more difficult to prevent intrusion. Not impossible, but you need that physical access. From a man in the middle perspective, it's no different than a cloud-based architecture.
Okay, well, we've gone a couple of minutes over, so I'm going to wrap things up. here. I want to thank all the people who've listened online to the webinar, also for the great questions. Thank you to the panelists, and thank you for the LoRa Alliance for hosting this.